then if people aren't here, can watch the video. There you go. All right, does everybody see this chart? All right, now, I don't remember how far we got yesterday or 2 days ago. We talked about this, right? 1, and then we had 10 and 100. These are called powers of 10, aren't they? Now, everybody on the planet, every human on the planet that deals with numbers, there's only one number system in the entire planet. And maybe that doesn't amaze you, but I know there's over 200 languages. There was not a language that was so good that everybody got rid of their language in history. But was there a system of measurement? Was there a number system that was so good that people got rid of theirs? When's the last time you saw Roman numerals in your math class? Hey, let's do math with Roman numerals. That didn't work very well. Everybody in the planet uses the same number system. So in around the 1800s, when this group of scientists in France said, we would like science to explode, but we're having trouble because the scientists in Germany are measuring with this system, and England with this system, and Russia with this system, and it's kind of confusing. They measure different ways. They said, what if everybody used the same system of measurement? That's what this chapter is called, measurement. And they had this great idea. They said, you know what? Let's base the measurement system on something that every human uses anyway. They already understand it. They already understand how many of these does it take to make one of those. What's the answer? How many of these to make one of those? 10. How many of these to make one of those? 100. Watch. How many of these to make one of those? I lost you. How many of these to make one of those? 10. How many of these to make one of those? It is 10. How many of these to make one of those? It's 10. How many of these to make one of those? It's 100. How many of these to make one of those? You see? That is the system. That's how it works. That's why everybody uses it. It's so simple. All right, so watch. One more time. How many of these does it take to make one of those? 1,000. How many of these does it take to make one of those? 10, right? How many decigrams does it take to make a gram? It has to be 10. How many deciliters to make a liter? How many decimeters to make a meter? How many decijoules to make a joule? I don't even know what a joule is. It doesn't matter. What? I never liked the metric system. What? You don't like powers of 10? Huh? Watch this right here. The third president of the United States, Thomas Jefferson. What did he do? He said, you know the number system they've been using in England and all that everybody likes? That's dumb. It's dumb. We're going to be the first country to use a money system based on what? Powers of 10. And how many dollars does it take to make a $10 bill? And how many dollar bills to make a $100 bill? And how many dimes does it take to make a dollar? And how many pennies to make a dime? And how many pennies to make a dollar? And how many pennies to make a $10 bill? It's amazing. You see that? If you understand the simplicity of this, you'll say, all right, maybe I could learn the metric system and actually like it. I think you would. Now, we do have to, the catch is you have to learn the prefixes. You get that? So we have to learn the prefixes, so I'm going to help you out a little bit here. Did we start memorizing these at all in class? Okay, let's try it. First of all, the ones in here, I think they taught you in elementary school, but if not, they should have done it in middle school. And if not, we'll do it here. How many had some teacher say, King Henry died at drinking chocolate milk? Have you heard somebody say that? Okay, so that's my memory trick there. King Henry died at drinking chocolate milk. That at least helps me with the first letter, doesn't it? Now, kilo means what? Kilo means what? 1,000. So, matter of fact, on TV shows, it's cop shows, about cops and stuff like that. When they hear about they had kilo of something, what do they really mean? Kilo what? Kilo, it's mass, kilogram, isn't it? And a kilogram is about 2.2 pounds. And so when they say kilo, it's just a short way of saying kilogram. But kilo is 1,000. Now watch this one. Hecto, 100. Hecto, 100. See that? Hecto, 100. Now these are confusing, but not really. Deca and deci. How many years are in a decade?
10.
Well, deca means what then?
10.
And which deca and deci, which one has the decimal?
Deci.
There you go. Deci has the decimal. Decade has 10 years. There's no reason you should tell me, oh, I switched those up. No, don't switch them up. Now, notice that little k is the abbreviation for kilo. Little h is for hecto, but these both have d. They can't both be little d. So the little guy gets the small abbreviation, little d. And what does deca have? I'm looking at your faces. What do you got? DA. Can you remember that? Okay, then a cent is 100th of a dollar. What's centi mean? 100th. And then milli is 1,000th of anything. Get that? So you got these? You got those 6? All right, let's go up to the big world. These are getting so large that even the abbreviation is capitalized. We have a lottery in, I don't agree with lotteries, but we have a lottery in North Carolina. What's it called? Mega Millions. Mega Millions, that should remind you that mega means a million. And anybody who's in the computer world, you know there's megabytes. And what's 1,000 times bigger than a megabyte? A gigabyte. And some of you have gigabyte computers, right? So many gigabytes of storage, of memory. But some of you in this room probably have a terabyte computer. Does anybody have a terabyte? You do? Okay, what do you need all that memory for? Are you a gamer?
I guess.
Okay. Some of the games now take so much memory that now they're into terabyte, you need terabyte computers to play some of these things. But a terabyte computer could probably store every song that's ever made in human lifetime. If you want all your songs, every one of them could be stored there, and every movie. That's a lot of memory. All right, so you ever got that? Now, what's the memory trick? Tera, trillion. Tera, trillion. Okay? I don't have a good memory trick for giga being a billion. I know it's gigantic. It's big. Okay, but it's a billion. Mega millions. Now it's going down here. Now here's where it gets a little tricky. Notice that the middle 6 have special names, don't they? But then you skip 10 to this is 1,000, this is a million, this is a billion, this is a trillion. The same thing happens when you get below here. 3 steps below milli is micro. Everybody see that? Now micro starts with what letter?
M.
So what's the abbreviation? Little m? No, you can't. I already used it for milli. How about big M? No, first of all, you're not big, and we already used big M. So they had to go to the Greek alphabet. And what is the Greek letter M? Anybody know? It's called a mu. And this is a mu, and I'll show you how to do it with a pencil. With a pen or a pencil, you make a U. Watch now. There's a U. And go to the front and put a little tail on it and make this noise. Go, whoop. Okay, let's everybody try that. All right, put your pencil down. Let's make a U. All right, and then, ready? Whoop. Okay. Well, anyway, and this is the way a computer makes the mu. It looks like a weird letter, doesn't it? And it's called a mu. And it's a Greek letter M, and it stands for micro. It's so small, you had to use a microscope to see it. All right, let's go on down. Nano. Nano. This is a millionth, and this is a billionth. Nano means a billion. And then we go down to here, pico. And pico means what? A trillionth. All right, so you're going to memorize these, all right? Let's look for some other patterns. The more patterns you see, the less you have to memorize things. Get it? The other day I talked about this. 100 has 2 zeros, doesn't it? how would your math teacher represent 100 as a power of 10, an exponent of 10? Wouldn't they say 100 is 10 to the second?
Yeah.
Or would they say 10 squared? I remember the first time I got to say 10 squared, I thought I was a big boy. You know, I got to say 10 squared. And have you said 10 cubed yet? Or x cubed? And what does x cubed mean? To the third power? What is 10 to the third power? That's 1,000. Okay? And what is 10 to the sixth? A million. And what's 10 to the ninth? A billion. 10 to the 12. Oh, tera, trillion, 12. Oh, little memory trick there. Now, here's the good news for you. I have good and bad news. If 10 to the third is 1,000, what is 10 to the minus third? 1,000. But 10 to the third has 3 zeros, but 10 to the minus third only has 2 zeros and a 1. Okay? I can learn that. What is 10 to the minus sixth? What's 10 to the minus 6? Well, wait a minute. Uh-oh. 10 to the 6 was a million, so what's 10 to the minus 6th? A million. Ah. What's 10 to the minus 9th? Wait, 10 to the 9th was a billion, so what's 10 to the minus 9? That's it. And what's 10 to the minus 12? A trillion. Got that? I think I got that. A little pattern there, isn't there? I got it. Now, I think I talked about this the other day. These numbers, they look like they're negative numbers, don't they? But for the first time in your life, you see a negative number. This is not a negative number. A negative exponent does not mean you're a negative number. A negative exponent means you're in the denominator. Did I do this the other day or not? Let's do it one more time. What is 10 to the minus second? If you want to learn this in math, if you want to take anything in the numerator and bring it down in the denominator, all you have to do is pay a price. And that price is change the sign of the exponent. So what's 10 to the minus 2 become? 1 over 10 to the second. And what is 1 over 10 to the second? That's 1 over 100. What is 1 over 100? It's 0.01, isn't it? That's what I said. Look. That's what it is. So it's not a negative number, it's a decimal number. Now I need you to memorize, listen, I need you to know that. I need you to know that when you have a negative exponent, it does not mean you're a negative number. It means you're a decimal number. Every one of these numbers here is found between 0 and 1. They're decimals. They're not negative numbers. They're decimals. Can you remember that? What do you think? All right, let's do something with this now, all right? Let's do something with this chart. I don't think we have turned the page. Did we do this all? Okay, I'm going to show you. Let's pretend that this is a pop quiz. It's not. But without looking, I want you to write down all the prefixes you remember us talking about and their abbreviation without looking. And then when you said, that's it, that's all, I can only do 2. And then you will look and fill these out. So I want you to fill this chart out. And by the way, I ran out of space. This is supposed to be, this is 10 to the 9th here. This right here is 10 to the 9th. There we go. And I'm going to make a little bar 10 to the 12th here. And then let's go down here. This goes down to 10 to the minus 9th, 10 to the minus 10th. Let's do 10 to the minus 12th here. All right, let's take about 2 minutes. I want you to write every prefix that you think you remember and its abbreviation. And when you think you said, I just can't remember it anymore, then flip it back and fill it in, all right? Let's do that. Remember King Henry died drinking chocolate milk? Remember that one? How many you remember? 1, 2, 3, 4. Okay. Don't forget your flashcards tomorrow, okay? We'll give you a grade for the flashcards. All right, how many you got? 1, 2. Okay. All right, start flipping it back over. Look at them. If you can't remember them, go look for them. When you get done, I'm going to show you something that you probably didn't think was possible. I'm going to show you how to do a metric problem that you used to hate, and now you're going to say, that was easy. You're actually going to say metrics are easy. Okay, I'm going to watch my time here. Anybody know 10 to the 12th? What's 10 to the 12th? What is it? Well, not terabyte, but it's tera, capital T. Tera means trillion, wasn't it? 10 to the 12 trillion. What about 10 to the 9th? A billion. Giga, which is capital G, is the abbreviation. Let's go down to 10 to the 6th. What's a million? Mega. Capital M. These are prefixes, okay? And what's 10 to the 3rd? Kilo. Little k, get that? What's 100? Hecto 100. Little h. What is 10? Deca. Some books, I'm okay if you put DEKA. I've seen DEKA, DECA, depends on if it's from England. If it's a book printed in England or Canada, Australia, they'll use, I think, C, and other people use K. And so what's the abbreviation for DECA? That's a hard one. Little d, little a. And then here, 1 is where there's no prefix. You don't use a prefix. If I say, give me a meter, it's just there's no prefix, is it? That's where meter would be. So I would find meters here. I'd find liters here. I'd find grams here. I'd find joules here. That's no prefix. Okay, what's a tenth?
Deci.
The one that has a decimal, right? Little d. What's a hundredth? Not yet. A cent is 100th of a dollar, isn't it? Remember, King Henry died drinking chocolate milk. Okay. Okay, now we got those. That's pretty easy. Now let's go down 3 more. What means a millionth? This is new for you. It's so small, I needed a what? A microscope to see it. And not a big M, not a small m. It's a Greek letter M, the mu, isn't it? It's a mu. Okay, next, let's go down to a billionth. Wow, this is really small. Nano. Little n. And then let's go to a trillionth. What's that? Pico. We'll get to those. That's later, okay? All right, now, I want to show you something in the next 5 minutes. I doubt when you first walked in, if I say get out a piece of paper, it's a quiz, 1,042,000 millimeters equals how many kilometers? You'd say, that's not fair. How am I supposed, I don't even like those kind of problems. And what I'm going to do is, I'm going to show you it's incredibly easy. And it's easy because they made it based on powers of 10. So what happens is when you go from one prefix to another, that's the same as moving the decimal. So what's going to happen here? I'm going to start at milli, and I'm trying to go to kilo. Now watch what I'm going to do here. Put my finger at milli. See this? Now go to kilo. And on this stair step, you don't go up and down, you go left and right. Ready? So you go 1, 2, 3, 4, 5, 6 steps to the left. I saw my finger move 6 steps to the left. So what am I going to do with the decimal point? I'm going to move it 6 steps to the left. Now some of you are out there, I don't see a decimal point. Okay, hey, let's get, hey, big boys and girls, everybody, if someone was going to give you $1,042,000, you think you might be able to find the decimal point? I don't know. Is it here? No, that's $1. Is it here? That's $10. You know where the decimal point is for a million. You know where it is. Don't tell me there's no decimal point there. Now, move the decimal 6 steps to the left. All right. 1, 2, 3, 4, 5, 6. And you'll say, that can't be, that's not the answer. Oh, yes, it is. Now, if I did 1,042,000 miles equals how many inches, that would take me all day to do that problem. This is too easy. That's why they built it. That's why the whole world uses it. They got rid of their system. They got rid of their measurement system. So, let's try it again. Let's try the next one. Ready? I'm going to skip that one because you're not sure what that is, and I'm not ready to talk about that. Let's go down to this one. 0.024 decigrams equals how many micrograms? All right, find deci. Where's deci? Decimal. And go to micro. A 1, a 2, a 3, a 4, a 5. I saw my finger go 5 steps to the what?
Right.
To the right. So, here's my original number, 0.024. Move the decimal 5 to the right. 1, 2, 3, 4, 5. The answer, 2,400. Now, if you've ever been taught the metric system a different way and you hated it, is this hateable? Is this almost like, what? It can't be that easy. Let's try a hard one. This is number 4. This will be our last one. 0.7 liters equals how many milliliters? Who wants to help me with this one? Who wants to tell me, Ben, how do you do this? I don't know where to start.
Well, start at 1.
Start at 1 because there's no prefix, isn't it? And where are you going?
All the way to million.
To milli? How many steps in what direction?
3.
Okay, so take this number here and move the decimal 3 to the right. Tell me what you get. So here's 0.7, 1 to the right, 2 to the right. What's your answer, Ben?
70,000. 700.
Yes. 0.7 liters is 700 milliliters. Whoa, that's not bad. This one we'll just make up a number here. What I'd like you to do, if you have time,